different techniques that we want to learn. Now, uninformed search is also called as blind search because we don't have information of the problem or any extra information. In normal language, clue of the problem domain is not there. So in a search space, wherever we are finding the goal, if you know certain properties, if we know certain uh, environmental conditions, if we have some sensor data, then that is called as information. So in informed search, some information is present, some mathematical relation is present, some sensor data is present, or something is there which is already known, termed as a knowledge. But in uninformed search, we don't have such any clue, knowledge. So this is what called as blind search or brute force search, wherein we randomly, approximately start our search, and we go or proceed towards search by checking one by one. So in this particular uninformed search, there are two techniques. First is called as depth first search, and second is called as breadth first search. Now, in depth first search, that is what our first technique and first algorithm of the search, right? This is also called as DFS, depth first search. Simple meaning is that we have to explore towards depth. We have to go towards deepest path. First of all, we don't have any information. We don't have any information of the problem. We have got this tree structure and we have to reach towards the goal. Now, in this case, what we are doing, we are going or exploring all possible nodes first. That is going by depth, right? Then come to this branch and then come to this branch. This is deepest branch. So we started with deep branch, right? Then come to here and then come to here. Now, when we implement this, the fringe, that is node list, is having LiPo stack. Last in, first out, that is what stack. So LiPo stack is there. It is not queue. LiPo stack is there. So whichever node is entered last, right, that will go first. That will go out first. So depth first search, see that these are different structure. So what we have to solve to problem, we have to go towards, this is what deepest part. So depth first, that means we have to go in a vertical direction till last part. So how search proceeds, this is shown here. So we start at S, D, E, F, F, F. So every time I am going towards the depth. Now out of these three, again see that this is deepest branch. So we have taken deepest branch first. So S, D, E, F, A, C. Now how it happens, this is just logic I am explaining you, right? Later on, we have to apply mathematically or procedure by procedure this algorithm to the tree. Right now I am explaining how to go towards depth. Now in that logic, question will be there, which will be first, D, E, P, or what will be taken first, right? That we will discuss in algorithm on in application. Right now conceptually, I have to go towards the depth part of the node or last node deep in the branch that I will be searching. Now this is what structure of depth first algorithm. So first of all, we are checking fringe is empty. So there must be nodes in fringe. If node is there, so remove first, right? Check that whether it is first node is, that is A. So A should be removed. Now tree will be expanded. So this is first node, root node. This has to be removed, and now we have got D, E, P, right? Then check that whether D is goal. If not, then take this path or record this path, generate successor node, right? Again add newly generated node in the list. Again rearrange all as per function of the algorithm, and again check that it is goal node or not. Again perform all the loop. Now procedure, that this is what algorithm for disperse search. So first of all, push starting node into stack. So stack will be now our fringe, that is what structure. Now this structure is like this. See that this is how fringe. So write fringe, and here there will be list of nodes. Later on this will go on. See that this is what called as fringe. Fringe means a structure where I am listing the nodes. So push starting node, that is root node, into the stack. Now check that whether stack is empty. If stack is empty, so search cannot be done. So we have to go back, right? Then if top node is goal node, check. If it is goal node, stop, and now your search is successful. Else now remove that node and find all neighbors. Again put them into stack and again go to 3. So first starting node you have to push, right? Check that stack is empty. Stack is empty, then you cannot search, right? That means only A is there, then there are no branches to A, then stack will be empty. So check that whether A is having branches or not. If this is first node and it does not have any branches, then there will be failure. So A must have further branches or further nodes, right? That's why this condition is added. Now once A is expanded, check that whichever first node is there, that is top node of the stack, right, in the list which is on top, right, whether this is goal. If it is goal, your search is over. If it is not goal, then remove that, record the path, and then find all neighbors. Again take all neighbors in the fringe and again rearrange them, and again check that whether they are goal or not. Now let us apply this algorithm. Now first of all, remember this is what tree structure we have done. So look at nodes. This is A node, this is root node, and preferably we will go for G. This will be our goal node. So this is what called as tree structure. This is what given in a problem, and we need to find the goal node or path for goal node. Path means A, B, D, C, A dash B, B dash C, D dash C dash G. This arrangement we want to find, and that is what called as path. Connection of the nodes is called as path. Now this is what given problem to us, and now we have to apply depth first search to apply or to solve this problem. Okay, now step 1, check that where is A. A is root node. Whether A is having branches, answer is yes. A is having branches B and C. So take root node in a fringe. So fringe is the list of nodes. Here we have to apply the stack, right? That is what LIPO logic we have to apply over here. So A is there. So take A in the list of nodes, that is the fringe. Next step, now remove A because A was on top, only one was there. So A has to be removed. So remove A and now expand A. It has got two children B and C. Now take, these are newly generated nodes, so add them in the list, right? So B and C is getting added in the list, right? A is there, so first A was added in a fringe. Now A has been removed, and now two children, that is B and C, are there. Now we have to decide where to go. So again see that B was on the top, so it should be removed, right? And D and E are the children of B. D and E are, so top of the stack will be removed. So who was on top? B. So B is removed. So we have C as it is remaining, and now B has to be expanded as a D and E. So now our stack becomes D, E, C. Now at the top of the stack was D. So D will be pushed out, and now C and F will be there. Already there are E and C, correct? So C is there. So D is removed. C, F, E, C was as it is. So top of the stack should be removed. That is what our logic. Now in this stage we were at D. D has got two children, C and F. Now top of the stack was C, right? And now you are having only one over there, that is what G. So G is there. So G was our goal node. So now path for this goal is A, B, D, C, G. So when we solve this problem, so at that time we have to apply these 6 steps or whatever, 6 steps or whatever many steps which are there. So we have to solve step by step, and then finally we have to write clearly this path, right? So your final answer will be clearly this path.